Okay, so for this lesson, we're just going to review transformations. Now, before we begin, make sure you have this sheet available in front of you to refer to, and it will make a lot of sense as we're going through this lesson. So here I have some data, and it's data of age versus height, okay? So when we're labeling each column, please make sure that you put the X and Y in front just to remind you which one is the explanatory and which one is the response variable. So obviously age in the first column will affect height, so we're going to call age our X age, and the second one will be height, so Y variable height. Okay, so we're going to plot the original data, and so the first question here, as you could see, is plotting the original data and getting the regression line. So to plot it, purple icon, X on X and Y on Y, and that's our data. And clearly what we're seeing here is that the data is not linear. And when data is non-linear, we have to put a transformation into it. If you want to further prove that the data isn't linear, you can just simply do a residual analysis just to double check. Okay, and to do the residual analysis, make sure you put a regression line on it first. And then when we do a residual analysis, we can see that we're getting a sad face. So sad face means that it's not linear. I'm going to remove that so that we can just focus on what we've got. And our question here says that the next thing we're going to do is to apply log 10x transformation. So we're keeping our y and we're changing the x to a log 10x. And if you refer back to this sheet here, and I'll just zoom in, log 10x transformation is this top one here. So when you transform this into a log 10x, your equation becomes y equals m times log 10 of x plus c. So please be aware of that. Okay, so let's go ahead and transform the data. We go back to our spreadsheet, and here I'm just going to say that I'm going to log my x. Okay, I'm going to call it log x age. Okay, and over here we're going to tell them what we want to do. So we're going to put equals, and then we're going to tell the calculator that we want to log base of 10. And in this area, we're going to type exactly what we've got in here, because we want to change all these values into the log of 10. So we're just going to go x age, and as soon as we finish typing that out, it goes bold, which means that the calculator knows which data you want to log for that. Okay, so please be aware when you're typing this in, it's always in this area. Okay, and you always start with the equal sign before you tell the calculator what you want. Once that's all typed in, you press enter, and all these values, all the x values here, is transformed into the log values. Okay, so now we've transformed the data. So question B is complete. Question C says to perform a regression analysis on the transformed data and comment on your results. So remember, regression analysis basically means you're fitting a straight line or a line of best fit onto the data. So there's two options you can do this. We can go back to our purple icon, and we can change the x to our log x. So if you click on it, we're going to transform the x to the log x. And there we go. So the data has moved, it has been transformed, and we're hoping that this transformation actually made the data a little bit more linear. Okay, so the regression analysis is the line of best fit, which, let me just double check. Oh, there we go. Okay, so transform it. The transformed equation is right there. So the equation is y equals 131.656 times x plus 6.93405. Okay, and to write it in context, we know that y is height, okay, in centimeters, is equal to 131.656 times, and now when we transform the x is no longer just x, it's going to be the log of x, which means in here, in this region, instead of typing x, we're going to type in log base 10 of the age in years plus 6.93405. This would be the equation written in context, and this is the equation that has this is the equation of the transformed data. So it's exactly as you would do for normal data, except the transformed data, you would have transformed all of one of the values, okay, one of the variables. Cool. And the other way of doing that, of course, is to use the linear regression. So menu for 1, 3, and we're going to do x will be log x age, and y will be height. And then we make sure that it's on an empty column, and our equation here is the same as what we've got down there, okay? Just don't forget this, whatever you transformed, you actually have to write the transformation down. That's why this sheet is so useful, because it actually tells you that your equation should look like this. If you did a different transformation, your equation will look also different. Okay, and you just have to follow this sheet. Cool. Okay, so back to our question, and it says use the transformed data to predict the heights of girls that are 7 years old, 10.5 and 20. So we can go to our calculator to do this. It's one of the ways of doing it, or alternatively you can always switch to table, but it's just much clearer if we just use our calculator, because we don't get confused with the two sets of data that we've got there. So to use the equation, we're going to solve, and then we're going to type in the equation. So y equals 131.656 times, and it's log base 10 of y, and our y, of x, our x is our age, and then plus 6.93405, comma, whatever you want. Okay? Comma, so in this case, we're wanting to find the height, so y is our height, and we can just go y, and we change the x, which is the age, to 7 to answer that first question. So we're doing this question here. Predict the height when the girl is 7 years old. So we replace the age with 7, okay, and then we want to find y, and then all we do is press enter. So apparently a girl that's 7 years old is predicted to be 118.2 centimeters tall. It's a prediction, okay? Now we can do the same thing for the next two questions, 10.5 and 20. Now we can just copy and paste. To copy, there's an easier way than the previous video that I showed you. So we can just highlight it and just click enter, and it will suddenly appear down here. And because we want to know about a girl that's 10 and a half years old, we're going to change the 7 to 10 and a half, and we're just going to hit enter, and there's our answer. So a 10 and a half year old girl is expected to be 141.38 centimeters tall. Okay, and for a 20-year-old, you'd be doing the same thing. So highlight and then enter to copy it down to the next line, and we can replace that with 20, and we're expecting a 20-year-old girl to be 178.22 centimeters tall. Okay, getting that so far? And then finally, we're predicting y instead. So it says predict the age, so our age is our y, of a girl who is 1.9 meters tall. So similarly, you would just copy and then just press enter. And instead of looking for y, we're now looking for x. We want to find out the age, and we know that the age is x in this case. So here we're going to replace the age with our x unknown. We're going to tell the calculator that we want it to calculate the age, or x, for us. And because we've been given the height of 1.9, we replace the height with 1.9. Okay? So instead of replacing x, we're replacing y, because that's what the question is asking. And once it's all in, we just press enter, and apparently a girl that is 1.9 meters tall. Oh, I made a mistake. It's meant to be 190 centimeters. I'm just going to redo that. 190 centimeters, because the height's actually in centimeters and I put it in meters by accident. So 190 centimeter tall girl will have a predicted age of 24.6 years old. So 24 point, let's go 57 years old. Okay, so the prediction is similar to just a normal linear regression, except we're using the transformed data instead. And because we've transformed the data, our equation is also transformed, and we use the appropriate equation to solve for us. Now, if you have a different type of transformation, you obviously use a different equation. So at the end here are all your different types of equations that correspond to each of these transformations. Okay, and just to reiterate what these transformations are, that's a logarithmic transformation, the second one is a reciprocal, and the third one here is a quadratic. Similarly, for this second box, the top is a logarithmic transformation, a reciprocal in the second part, and the last one is a a quadratic transformation. Okay, and the reason we have two sets is because our data, when it's not linear, can be curved like a rainbow. So I call this rainbow, or it can be curved like a J. Okay, so if you have to apply a quadratic transformation on a curve that looks like this, you'd pick this one and not the one up here, because this one's for a rainbow looking shape. Okay, which is what we had in this question. This is a rainbow one, so we would obviously use the top half as our transformations of choice. I hope this helped. If you have any problems, obviously email me or come and see me at school. Yeah, that will be all. Thanks.